equal to 0 equal to 0, we would get -1 and -4. So then when we go to our number line, we're going to say that -4 and -1 are the critical values on our number line. So we'll go -4 and -1. Now, just a thing to note, when it says or equal to, just like if you had x is less than 5, you do open circle, versus x is less than or equal to, you do close circle on the number, we know that these are going to be closed because of the original inequality symbol. Now you can only look at it when it's not a fraction. It's a little bit different when it's a fraction, when it's a ratio, like number 3 and 4 and so on. So we need to test the critical values, which were -4 and -1, or you can just look at that symbol. We know they're closed circle, and values in the regions in between and on either side of those critical values. So let's just show that for those critical values it works when you plug in. So if I plug in -1, -1 squared, -1 squared plus 5 times -1 plus 4, we have to say to ourselves, is this less than or equal to 0? So I like to put a little question mark above. So I have 1 minus 5. So 1 minus 5 is 1 minus 5 plus 4. So that's -4 plus 4 would be 0. So is this true? Yes, because 0 is less than or equal to. So that's why we did a closed circle. So it's going to be the same thing when you plug in -4. So we test a point in all different regions. So if I test a point in here, you can pick any value. I'm going to test -2. So -2 squared is 4. 5 times -2 is -10. And if we add another 4, we would get 8 minus 10 would get us, so 8 minus 10 would get us -2, and that is also less than or equal to 0. Check. Now, if we have to test points in the other regions. So if I test, let's say, something to the right of critical value, the number -1, if we plug in 0, you can pick any number. 0 squared is 0. 5 times 0 is 0. Plus 4 would get us 4. And is 4 less than or equal to 0? No. So we cross off. And that's if we tested the number 0. You can pick any number bigger than -1. If I plug in any number less than -4, let's say -5, we test -5. -5 squared, so let's see this over here. -5 squared plus 5 times -5 plus 4. Let's see what we would get. So we get 25 minus 25 plus 4. So that would get us 4. And is 4 less than or equal to 0? No. So therefore, our answer, interval notation, is just in the shaded region, right? You do brackets if included. So we start looking from left to right. We see shading at -4, comma, wherever we stop at -1. And it's closing, so that's our answer. Okay, then let's try number 3. Remember, you're going to do the evens as homework. So we're going to pretend it's an equals, right? So if I had x plus 5 over x minus 4 equals this. First of all, we need to always set any denominator equal to 0 and solve, because those are critical values. So first, you set denominators to 0. So if I set x minus 4 equal to 0, I would get x equals 4 So that's going to be one of our critical values. And then if we solve, right, if I had x plus 5 over x minus 4 equal to 0, and then if I chose to put this over 1, and then if I cross multiplied, I will get 0 is equal to 1 times x plus 5 or x plus 5. And when I solve that, I would get negative 5 equals x. So my other critical value is negative 5. And then when we go to do our number line, we have our critical values on our number line. So we would have negative 5 and 4. Now, when you look at this, you have to be careful with when you have fractions and your critical values. You can't just look at the symbol and assume that they're both closed circles. So let's test. So if I put 4 in, I would have x plus 5, right, over x minus 4 less than or equal to 0. So on top, 4 plus 5 would get me 9. And in the denominator, 4 minus 4 would get me 0. And is 9 over 0 less than or equal to 0? No, because it's undefined. So that would be open circle. Then negative 5 plus 5 is 0. And 0 over negative 4 is 0. Is 0 less than or equal to? Yes. So basically, your critical values when you set your denominator equal to 0 will always be open circles. And then you can always look at your what you get when you solve those critical values, and those go with the original symbol. So because of this, it's a closed circle. But your denominators, when you set those equal to 0, they're always open circles because they're always going to be undefined values. And then your other values, when you solve later down the road, you can look at the symbol for open and closed circle. James, turn that down. Okay, then we can look at different values in different regions, so in between and on either sides. So if I test 0, 0 plus 5 is 5, and in the denominator, 5 minus 4 would get us 1, and is 5 less than or equal to 0? No. Right? Now if I test, let's do positive 5. 5 plus 5 would get me, let's say we're testing 5. 5 plus 5 would get me 10. And the denominator, 5 minus 4 would get me 1. And is this true? Is 10 less than or equal to? No. Now, if I plug in, let's say, negative 6, negative 6 plus 5 will get me negative 1. Negative 6 minus 4, negative 6 minus 4 would get me negative 10. So is 1/10 less than or equal to 0? Yes. So we would check that and shade this region. So you look from left to right when you're stating your answer in interval notation. So we would say negative infinity. Infinities aren't a finite number, so we do parentheses, comma, I stop at negative 5. It's closed circle, so there's a bracket. Now, since nothing else is shaded, I don't have to write union because 4 is an open circle, so we're done. The shading lies between negative infinity and negative 5. Okay, I'm going to do one more and then I'm going to create another video because you can't have videos over 15 minutes. So, if you set each denominator equal to 0 and solve, you would get x equals negative 5, and you would get x equals negative 6. So thing number one, you have critical values when you set your denominators equal to 0, and then you also need to solve the problem. So if I solve this and I cross multiply, I would get 8 times x plus 5, you've got to pretend it's an equals, right, is equal to, I'm going to put the negative on top in the numerator, negative 7 times x plus 6. So if I distribute here, I would get 8x plus 40 is equal to distribute your negative 7, so you get negative 7x minus 42. Now we've got to solve for x, so you can move x on either side. If I move this over here, add 7x, we get 8 plus 7 is 15x. And if I subtract 40, over here I get negative 82. And if I divide by 15, I'd get x equals negative 82 over 15. And let's see what we get. So that would be negative, that's about negative 5.5 as a decimal. So let's go and draw a number line. We have our critical values and then whatever we get when we solve, okay? So when I put my critical values on the number line, I have negative 6, I have negative 5, and I'm just going to say negative 5.5, but we really know that's negative 82 over 15. Okay, the denominators are always going to be open circles because those would be undefined values. So we know we're going to save time, open circle, open circle. Now, when you solve the equation, whatever you got, those you can look at your symbol. So because it's or equal to, I can do a closed circle on negative 5.5. Okay, plug in values in different regions. So I'm going to plug in 0. So 0 is right here. And if I plug in 0, I would have negative 7 over 5. And is that less than or equal to negative 8 over 6? So let's see. So 7/5. So we have negative 1.4. And is that less than or equal to negative 1.3? Yes. So we would shade in here. If we plug in a value in this region, let's say we plug in negative 5.1. Let's see, negative 5.1 plus 5. If I plug that in, negative 5, let's say we're doing negative 5.1.